Hello, I am Dr. Athar. This is lecture number 3. Let's discuss few operators today. These are logical operators which results in true and false. For example, this is a greater than sign, this is a less than sign. For comparison, we use two equal to signs, which is used for comparison. And we have a bitwise AND, bitwise OR, and bitwise NOT. Bitwise AND correspond to a logical AND gate used in digital electronics. Bitwise OR corresponds to a logical OR gate in a digital electronics. Similarly, bitwise NOT corresponds to a logical NOT gate. Bitwise AND works like this: when any bit is 0, output will be 0 regardless of another input, regardless of another bit. Similarly, when in bitwise OR, when any input is 1, output will be 1 regardless of another input. Similarly, bitwise NOT is not of 1 is false or 0, or not of false is 0, not of 0 is 1. So when you want to compare two variables x is equal to y, we use double equal to sign. When you want to assign y to x, we use single equal to sign. This is for not equal to, this is for greater than equal to symbol, less than equal to symbol. Let's see an example. In this case, we are having three variables: a is equal to 3, b is equal to 4, and we have three variables: result and result or result not, and we are initializing with 0. In first result and we are assigning it to a and b, so it will do a logical AND between a and b. So the result will be 0 because any input to AND is 0, output will be 0. Similarly, a or b will result 7, and not of a will result flipped of a version. So and in the end we are just printing these three variables. So let's just run it. So these results are true. I will try to explain the bitwise OR, bitwise NOT, bitwise AND in a coming lecture, so it will take some more time. So for the meanwhile, you can just know how to use these operators, and these results are correct. So let's take another example. Let's just first run go to statement, first run go to statement, then we will come back. The go to statement are used for unconditional control transfer. It is used to transfer the control to a specified label in a same program without evaluating any condition. It is an unconditional jump. The go to statements are never recommended because it breaks the flow of code. So how it works, let's see an example. In this code we are we are taking a number from a user and testing it whether its number is greater than 0. That is, it is a positive number. When the number is positive, we are printing it as it is an even number or odd number by using a mod operator, because mod operator give us a remainder. For even number, when we divide by 2, the remainder will be 0, so it is an even number. As it will be odd number, as if the number is not greater than 0, it will be 0, or it will be less than 0, meaning that it will be a negative number. And then we are printing goodbye. So we want to repeat the same code again and again, so we label it with a keyword again and with a colon. So this is a label, and we are jumping into this label unconditionally again and again with a statement go to and again. So it will repeat the code again and again. Let's just run it. So 56 is an odd number, 56 is an even number, so it will print even number and goodbye. So it is again jumping to the label unconditionally. So 21 is an odd number, it will print odd number, 8 will print odd number and goodbye. For 0 will print number is 0, goodbye. For -7 it will print it's a negative number. So this is an unconditional jump and repeating again and again. So in order to stop it, you have to use Control C, because there is no terminating condition in it. So go to statements are never recommended. Next is we want to study a ternary operator, conditional operator, because it's ternary because we have three operands, three parts of the instruction. In first part we test the condition, then we use a question mark, which is a part of the syntax. Then if the condition is true, the first block of code is run, which is a true statement. Then after full colon, the false part are executed, which shows the third part of the conditional operator. So if grade is greater than 90, so it will print pass. If grade is less than or equal to 90, it will print fail. This can be executed with the if-else structure. If grade is greater than 90, it will print pass, else it will print fail. So let's just check it. You can see we are taking a number from user, my marks, and we are comparing it with a conditional operator. If my marks is greater than 90, we are printing pass, else we are printing fail. We can implement the same code using a if-else structure. If my marks is greater than 90, we are printing pass, else we are printing a fail. So meanwhile we put in the comment, we are running it using a conditional operator, using a conditional statement. Let's just compile it and run it. So if I enter 99 on an 88, it will print fail, while for 99 it will print 98, it will print pass. So the conditional operator is working fine. You can also assign the result of a ternary conditional operator to a variable. For example, in this case, if hour is greater than 40, it will assign 3.50 to rate. If hour is less than or equal to 40, it will assign 0.25 to rate. Next, we will study post increment and pre increment, and post decrement and pre decrement. In this case, x is equal to 10 and y is equal to plus x. So in pre-increment, which is plus x, the x will be incremented first by 1 and later it will be assigned to y. So x will be 11 and 11 will be assigned to y. So x is 11, y is 11. While in other case, first x will be post increment, x will be assigned to y, so 10 will be assigned to y, and later x will be incremented by 1. So x will be 11 while y will be 10. Similarly for decrement case, in pre-decrement, first x will be decremented by 1 and later it will be assigned to y, while in post-decrement, first x will be assigned to y and later x will be decremented by 1. Let's see an example. In this case, x is incremented by 1 after x is assigned to y. So x is 0, so 0 will be assigned to y and x will be 1. In the next statement, x will be 2 and 2 will be assigned to z. So it will print x will be 2, y will be 0 and z will be 2. So 202 is answer. Similarly, in decrement case, x will be decremented by 1. Later, when first x will be assigned to y. So y will be 0, x will be 9. In this case, pre-decrement, x will be decremented by 1, so x will be 8 and 8 will be assigned to z. So it will be 8, 0 and 8. Statements are running fine. So that's it. In the coming lecture we will go ahead and we'll learn more advanced concepts. Thank you.